Find the area of the region trapped between the curve y is equal to x, x minus 2, x plus 3, and the x-axis. Well, let's sketch what we're trying to find. So if this is the x-axis and this is the y-axis, then -3 is going to cut at the origin as well, and 2. If we expand this out, the x cubed term would be positive, so that tells us the shape is going to be like this. So it's going to come over here, down, under, and up here. So this is y is x, x minus 2, x plus 3. And the area that we want is the area here added to the area here. But as we discussed in the notes, this area is above the axis, so would come out positive. This area is below, so would come out negative. So if we just integrate from -3 to 2, this area will cancel off of this one. So in order to do this manually, what we need to do is first do the integral from -3 to 0, and then we'll do the integral from 0 to 2 separately. We could do with expanding this out. So we have x squared minus 2x plus 3x, so that's plus x, take away 6, so that's going to give us x cubed plus x squared minus 6x. So x cubed plus x squared minus 6x dx. So that will give us x to the 4 over 4 plus x cubed over 3 minus 6x squared over 2, which is 3x squared, and that's from -3 to 0. So the top is giving us 0, and the bottom would give us 81 over 4, take away 27 over 3, and that's going to be take away 3 times 9, so that's 27. And I think we'll just calculate that on the calculator. So let's just clear everything we've got. And if we've got 81 over 4, take away 27 over 3, that's just 9. And then take away 27, that's -63 over 4. With this negative here, that's going to be 63 over 4 square units. Now, we also want the integral from 0 to 2. So this bit gives us this area here, and now we want this area here, of x cubed plus x squared minus 6x dx. Well, obviously it's integrating to the same thing, so it's x to the 4 over 4 plus x cubed over 3 minus 3x squared, and there we're going from 0 to 2. So that's going to give us 16 over 4, which is just 4. And then we're going to have 8 over 3. And then we're going to take away 12. And obviously the bottom limit's going to give us 0. So we have got 4 add 8 over 3, take away 12, and that's -16 over 3. Now, the negative just signifies the fact that it's below the axis. So actually the area is 16 over 3 square units. So to get the total red area, all we need to now do is 63 over 4, add 16 over 3. So again, we'll just do that on the calculator. So we've got 63 quarters, and we're adding 16 thirds. So that's 253 over 12 square units. Now, on the calculator, what I'm going to do is I'm just going to integrate from -3 through to 2 our x minus 2 and x plus 3 dx, and that gives us 125 over 12. Now 125 over 12 is what we get if we do 63 quarters, that's the area above here, and we take away 16 over 3. So you can see these are the same, and that's because this bottom area is cancelling off of the top area if we just integrate all the way. Now we've seen manually that if we do the two parts separately we can come to the answer, but there is a way of doing this on the calculator. What we do is make use of the absolute value function. So if I come back to this and we'll put that in modulus, and then if we execute again there, we get 253 over 12. So how is that working? Well, we know that the modulus function will give us a reflection on this part, and therefore with the modulus, if we do the area all the way from -3 to 2, both areas are above and we can just put it all together.